Thank you. And it also supports LFE as well as pretty much any Beam language that just uses a standard function and allows tracing. Okay, so Erlyberly is a Java desktop app. It connects to a remote node using Erlang distribution. So when you do call nodes in the remote node, it appears just like a normal Erlang node with a private connection. It uses the JInterface library as integration for this. So JInterface is a Java library that implements the Erlang distribution protocols and handles network sockets and everything like that. So when it starts up, it loads the Erlyberly beam into the remote node and then calls functions on that loaded module to apply traces and get other informations. So when it applies traces, and those functions are called on the beam, they will send trace messages to the tracer process that it starts up, because it uses DBG under the covers, and they'll be forwarded to the Erlyberly JVM through Erlang distribution. Okay, so motivations for using this. There's already DBG and Redbug and other great tools. So the reason for initially starting it was that the trace API can be quite large, quite difficult to navigate, especially if you're starting out using Erlang and you want to debug. Especially again, if you're a Java developer, more used to the Java debugger. You expect something graphical rather than going through DBG APIs. Erlyberly also gives you some analysis of results, so it tries to give you more information or convert the information you get from traces into something more readable or something with a bit more information. It also incorporates other tools that I found along the way as I was writing it. Sometimes written by other people, brought them into Erlyberly and gave them a user interface, tried to document them a little bit so they're a bit more discoverable as well. So getting our first traces. On the left-hand side, you see a list of modules and functions. That list will show you whether the function is exported or not, and there's a checkbox there telling you whether it's traced or not. If you double-click or use the shortcut Control-T or Super-T for Mac, then the traces will be applied and you see the tick box checked. And after that, the function calls will send traces into the table. In the table, you get the PID. Erlyberly pulls out the registered name for you as well. The function call and the arguments and results where they'll fit into the table. It also gives you the duration in wall time, so it's not quite good enough for profiling, but it gives you an idea of how things are performing. And because it's always there, you get a sort of background knowledge of how your code is working. But it's wall time, so it does include garbage collection and descheduling. So if you double-click on one of the trace logs, you'll get this breakdown. So the arguments and the results at the top, so shown in a tree format, which you can scroll down and navigate. It's a bit easier than going through just a block of Erlang terms. You also get the stack trace, so you can see what's called, which is especially good if you're tracing a module which is quite generic. So if you're tracing something in dict or lists, which is probably called all over the system, you can find who's calling that module. How that works is that you send the process dump flag in the match spec when you're tracing, and that gives you back a binary for each trace. I couldn't actually find the format of that binary process dump, so I lifted a bunch of code out of Redbug. So thanks to those Redbug people that have contributed to that project to make it dead easy for me. So On some tracers, for OTP behavior callbacks, we can actually annotate the records for the arguments and the results. So we can do that because we know that the last argument of the function and the last element of the result tuple is going to almost certainly be some sort of state record. So what Erlyberly does is go into the beam, get the AST out of that, find the record definitions, and then add the record metadata to those trace terms and send that to the user interface, which can then use that to highlight those fields on the user interface. It'd be really nice to do that for other functions, maybe use dialyzer specs to find which functions were using records at which arguments, or what if it was returning records. That's a possibility in the future. So Erlyberly also allows you to decompile funds that get passed to it via tracers. So it does this by sending the fund back to the remote node and running some code that I found in a great repo called sailing/util on GitHub. So it was another happy discovery that I was able to do this. If you're using loads of funds in your code like I do, this is really useful. So in this example, we've got a fun from React KV query compiler, which has loads and loads of funds in it. It has a fun for each type of thing you can do in the select statement of an SQL query. So there's one type of fun for just returning a column, one type of fun for returning select star or count star. So there's loads of different types. So being able to decompile that and see what it's actually running is really useful. Yeah, and thanks again to Sailing for writing that. Check that out because it's got a user default module in there which you can put into your shell. It's got loads of cool utilities. You can also get the process state from an OTP process. So this is user interface over sysGetState, which you could call directly from the shell. The advantage of using Erlyberly is that, like in the tracers, it will annotate the record with the field names in the same way as it will in the trace logs. Just so you can see what's happening. You don't have to count through the tuple elements. It does have the same restrictions as sysGetState, so it has to be an OTP compliant process. You can't do it on a raw process. The reason for that is that it has to support the sysGetState message, or it won't understand the message it receives. Erlyberly supports xref, so you can see what function calls all the way down. You can see what those function calls as well. And it integrates well with the tracing. So on the right-hand side, when you see that at the top, doput calls prop lists and React Core, you can put tracers on those, and you can also recursively put tracers on all functions so that it calls and that those call, so you can see all the executions all the way down the path. To start that, you have to click the button at the top, xref analysis. That starts xref analyze on all the paths that the VM knows about, apart from some weird ones like megaco and a few others. So it skips those because it just takes ages. This takes quite a long time anyway, so I've tried to remove as many paths as I could. It also takes loads of memory for the lookups. So when you've done that, right-click a function, view call graph, and it will generate that lookup. Kind of a nice pie chart for the Erlang memory, which you could call directly, but yeah, pretty. You can also select a bunch of processors. See if I can get the demo for that. So for example, so this is what I was talking about with xref. So what I've done now, oh no, okay. Thank you. Yeah, so you get a pie chart of all the processors used there, or you can select maybe everything except Erlyberly XREF, which is holding all the things. So that's much more spread out now. So this is connected to React.ts. At a guess, these are all vnodes or something to do with vnodes because it's all really evenly spread out. And then this big one is all the processors that are too small to fit in the pie chart. See if I can get my... So Erlyberly can give you decompiled source code. So if you select a function or a module, it will go into the Beam file on disk, which has to exist, and it needs debug info as well. Pull out that AST, pretty print it, and it can display it on there. It's kind of useful just for browsing around if you're not that familiar with the code base or you've hot-loaded like a bunch of different versions. Thank you. And you're not quite sure which version it is anymore. So same again, but with AST, you can see the AST for a module. I use this quite a lot because I enjoy writing parse transforms, and you can see what the parse transform is actually producing. Because you can't see otherwise the intermediate stage of, you've got the source code, you've got the parse transform module, but you can't see what it actually produces. You can only see the, well, you can execute it, that's how you can see it, except for the AST. Also, we use Merl quite a lot to generate modules, so that's really cool if you're just dynamically generating code. Workflow is really important as well in Erlyberly. This was one of my main frustrations as well with DBG. So if you've got a workflow, like you have a problem, and then you do some tracing to find the issue, you change the source, and then reload the module without stopping the node, then all the traces on that module are lost. You won't get any more trace logs from function calls to that module. So what Erlyberly does is put a trace on the code module. When that's called, it means a module is being reloaded right now. So when it sees a trace from the code module, it knows this module is being reloaded. It understands the function signatures of the code module to pull that module out, and then it will reapply the traces on that module. So that's all completely transparent. You won't see any lost traces typically, unless it's some sort of race condition with reapplying those traces. Otherwise, you'd have to go through your shell history, reapply all those traces. It's just not quite as slick. Also, if the node goes down for any reason, like it crashes, or you need to take it down because you've modified supervisor or record structure, then Erlyberly will keep trying to reconnect, and when it does reconnect, it will reapply all those changes, which saves time as well, because when you close the node, you've probably lost the shell as well. So you don't have the shell history to reapply those traces. So automatic reapplication of those traces is really useful. And it just means you can carry on testing as you were before. So you test, you've made a change, you retest in the same manner, and you should see the changes. Looking for contributors. We've already had a couple of people from Erlang Solutions in London contribute some features and fixes. That's been awesome. So thank you to Andras and Ruan in the London office. If you don't want to get involved in code, there's things you can do. So the wiki is publicly editable. You can document any features which you think aren't documented well enough. Raise issues include the exception and the versions and what you were doing at the time. Screenshots also. Screenshots are a nightmare to keep up to date. Every time I add an image, a button to the user interface, I have to update all the screenshots on the README, which is just loads. It's a constant pain. So if you see any of those that are out of date, you could PR on the README, or there's an issue where you can just add any screenshot you want as a comment. Doesn't matter what it is, doesn't matter if it's a fix, just if you're doing something cool and you want to share it. If you do want to get involved in the code, this is a great issue. So number 94 in GitHub, Elixir syntax formatting. So at the moment, we support syntax formatting for Erlang and LFE. So if you choose those in the preferences, the syntax formatting shown in the tree that we saw earlier will come out in the format. So for LFE, you'll get round brackets for lists. For example, Erlang, you'll get square brackets. But there's nothing for Elixir yet, so you just need a formatter, so something that takes the Erlang terms and produces Elixir representations as a string. So if you're interested in picking that up, especially if you're using Elixir all the time and you're seeing problems in Erlyberly, because I rarely use Elixir. I checked a while ago that it did work with Erlyberly, but then I don't use it day to day, so I probably don't feel the pain that some Elixir users are feeling. Yeah, just let me know if you would like to pick that up. Yep, and that's it. Do we have time for a demo? Yes. And some questions afterwards, maybe. So I'll just hide the processes. Because it's like this app really benefits from a massive monitor, so the bigger monitor you have, the better it's going to be for you. So some secrets of the filter: you can filter all the modules. So you can also, there's a configuration flag in there to say load everything, every module with the name React in it, which is kind of useful. So doing that will show you all modules that contain the string React KV query. If I don't know the module name, but I want to do the function name, I can just do colon and leave the module part empty, so it's just a FA. I can even do and it will just filter that for you. So this is a contains, and it is case sensitive, which also might be a pain for Elixir since those functions are cased. So I'll just find the function now. So these are all the functions in the module React KV query compiler. So if you just want to trace everything that appears in this, it's a little bit dangerous. But it's just, if you know it's not too many functions, if you've got a filter at all, Control-Shift-T or Super-Shift-T for Mac, that will just apply traces to everything. So even if you have multiple modules, it will apply traces to it. So now, if we do a query, so I know that this query will require it to be compiled by React.ts, and that will call a load of functions in that module. We get those functions. So we can see the import was, this is a record, DDL_v1. We can see the stack trace. We can go onto the stack trace, find what the function does, and how we've got to this place. Also, at the moment, this is development time only. So we're working on some overload protection. So if you get a big loop that you're tracing a function on that sends hundreds of thousands of trace logs, then that could completely overwhelm the system, previous to some of the changes that went in the last month. So now there's some very basic protection where on each trace that's handled, it will check the message queue. If the message queue goes over a certain size, then DBG will just be stopped and you'll get suspended and you won't get any more traces. Also, there's a limit to the number of traces that the user interface can hold. Of course, anyone that's just left Erlyberly overnight with maybe timers ticking every minute or so usually find in the morning that it's crashed without a memory, because it would just take all the messages that he had, however big they were, and load them into memory and try to show them as strings. It's still not quite safe for production, but if you've got any stress test systems, I'd really appreciate any testing that you could do. So run it, try and break it, and let me know if you can break it in the most horrible way, especially if it's reproducible by myself. That's it. Thank you. Questions?
Got time for only one question.
Okay, so have you done some performance comparisons with other trace tools?
No. So this is why it's only development time. Of course, it adds so many other features like the record annotation. I know for a fact that it's going to be slower. So if we did want to use it in production and we were worried about performance, there'd probably have to be some safe mode where all these extra features were removed, so it wouldn't do any annotation or anything like that, just because if you really want to be safe, you want as little code running on the Erlang side as possible, just so as little as possible could go wrong. So I know it's a lot slower, but it's just because it's doing a lot more at the moment.
All right, thanks very much.
Thank you.